Okay. Hello my dear students, I welcome you to NEET World. So in this session we will be discussing EAPCET, Telangana EAPCET 2025 question paper. Okay, so as I mentioned before that these sessions are very useful for AP EAPCET students. Okay, so those who are attempting AP EAPCET 2025 exams and also other state level like engineering or any other exams after 12th. So these sessions will be definitely a wonderful sessions for them. This will be giving you like very high like benefit. Okay, so you can get more benefit from this session, these live sessions. Okay, so you can watch these sessions, and also in this particular session I will be discussing EAPCET, Telangana EAPCET, that is for MCET student, MPC students, which is happened on 3rd May. Okay, so this is from 3rd May, second shift paper. Okay, so you can watch completely and you can write your feedback in the comment box, so that we will get so what you are benefiting or how you are using these particular sessions for your preparation. Okay, so you can also ask us whatever the sessions you are expecting from us for your preparation. Okay, so let us start our session here. The first question here we have: in the atomic spectrum of hydrogen, the wavelength of spectral lines corresponding to the electronic transition from 4 to 2 and 3 to 1 are lambda 1 and lambda 2 respectively. The value of lambda 1 minus lambda 2. So this is what the question they are asking. So just tell me whether my voice is clear or not, everything is clear or not in the comment box. Okay, let me start this. Okay. So let us start this session. So how can we solve this question, tell me? So in the hydrogen spectrum, atomic spectrum of hydrogen atom, so how can we write the wavelength? So we have formula Rydberg's equation, 1 by lambda equals to RH square by 1 by N1 square minus 1 by N2 square. This is a formula we are using now. Okay, so now for hydrogen atom, so Z value, atomic number will be 1, so I can write RH, that is what Rydberg constant. So lambda 1 equals to RH 1 by N1. What is the value of N1 here? So from 4 to 2, the smaller number you can take here, N1 square, so 2 square, that is 4, minus 1 by N2 square, so that is 4 square, that is 16 here I am writing. Okay, now similarly 1 by lambda 2 I am writing, that is for the second one. So 1 by lambda 2 RH, okay, 1 by, what is the small value here, 1 square, it is 1 again, 1 by 3 square 9 I am writing like this. Okay, I think up to here it is clear. And the next what we can do from here, so I am writing here 1 by lambda 1 equals to RH. So by simplifying this, 16 in the LCM will be 16 here I am taking. Okay, so here 4 minus 1, that is what we will be getting now. So from this we will be getting RH, 4 minus 1 is 3 RH by 16, that is 1 by lambda 1. So I can write lambda 1 equals to 16 by 3 RH, like this I can write. Similarly 1 by lambda 2 I am writing 1 by lambda 2 equals to RH, okay, into, okay, LCM will be 9. Okay, so here 9 minus 1, that is 8 by 9. Okay, so from this what I can write, the inverse of this we can be we will be writing now, 8 RH by 9 you can write. So from this lambda 2 will be what? So 9 by 8 RH, 9 by 8 RH. Okay, like this we can write. So now what they are asking, lambda 1 minus lambda 2. So lambda 1 minus lambda 2 they are asking. So lambda 1 is how much? Lambda 1 is 16 by 3, okay, RH, okay, minus lambda 2 is 9 by 8 RH. Okay, we can write like this, right? I hope up to here there is no confusion, nothing now. So by simplifying this, so what we can get? So LCM will be how much? So that will be 24. Okay, 8 3 is 24 we can say, and 16 8 ja minus and see 8 24 when it will be coming, so 8 3s are and 8 3s are again, so 3 9 3s are 27, so you can take it here. Okay, so this is 128 minus 27 by 24. Okay, so what is common here? RH is common, so I am writing RH here. Okay, so from this is in the, this is RH is in the denominator. Okay, so we will write here RH. Okay, like this we will be writing. Okay, so from this what we can get? So from this we are getting 101 by 24 into 1 by RH. So do we have any options like this? So 101, so let us see option, so just remember this value, let us see for the value 101 by 24 into 1 by RH, this should be the answer here. So 100 by 24 into 1 by RH. So our option 3 is correct. I hope it is clear, there is no confusion now. So these are the steps, whatever we have did, those steps you need to follow. So if you want, you can go back again by clicking 10 seconds back, and you can watch it, rewatch it for getting more clarity. Okay, so this is about the first question. Okay, the starting question itself little lengthy and little difficult you may feel while solving it or while simplifying it, but it is easy only. Okay, then next here we have the work function of 4 metals is given. So this is based on photoelectric effect. The same concept you will be studying in both physics and chemistry here. So what we have? So work functions are given for 4 metals here. Okay, these are the work functions. Now respectively, the metal which do not show photoelectric effect. Okay, so what do we know about photoelectric effect? We will be seeing now. So which will not show photoelectric effect when the wavelength of when the light of wavelength 310 nanometers falls on the metal surface. So how can we do this? So if we take a metal surface, let us understand the photoelectric effect. Let's have some basic idea. So this is a metal surface, you can say. Okay, so on this metal surface we know electrons will be present, like on the metal surface, on the atoms of metal electrons will be there, right? So whenever a source of light is hitting on this metal surface, falling on this metal surface, if this light is having sufficient energy to excite these electrons from the metal surface, so that energy will be, see, in order to bring out this electron from the metal surface, some energy is required now. Okay, so the supplied energy, if the supplied energy is sufficient to remove this, to bring out this electron outside, if it is sufficient, then only photoelectric effect can be observed. Okay, now the supplied energy is lesser than the energy required to bring out this electron out from the metal surface. If it is less, there is no photoelectric effect is observed. So now the minimum amount of energy, that is what the minimum amount of energy required to bring this electron out is called as threshold energy, and frequency as threshold frequency. Okay, and these in terms of photoelectric effect we will be calling it as work function. The work function means what? The amount, the minimum amount of energy to bring out the electron from this metal surface by supplying some heat or supplying some light in the photoelectric effect process. Okay, so if that is the, so what is work function? That is a minimum amount of energy to bring this electron out from the this metal surface. Okay, so the minimum amount of energy or the frequency required to eject the electron from the metal surface is called work function here, or the threshold frequency in terms of frequency. Okay, so now, so these are the frequencies, these are the values, energy values they given for photoelectric effect. Now, so now what they are doing is, so these are the threshold like work functions for different metals. 4 metals are given here in terms of electron volt. Now, so this is the amount of wavelength they are incidenting. The wavelength of this the wavelength which is falling on the metal surface is how much? 310 nanometers. Now we have a formula delta E equals to 1240 by lambda in nanometers, you can say. Okay, so like this, using this formula you can get the value of this like in terms of electron volt you will get the value of this this wavelength. This is the wavelength they are incidenting now. So if we get the value, exact value of energy associated with this wavelength, we can expect whether the metal is showing photoelectric effect or not. Okay, so now here what is the value they mentioned? 12400 by 40 by lambda, what is that? 310. So I am writing 3 times. So 0 0 removed. So this will be how many times? 4 times. So 4 times we will get. So what is the value here? 4 electron volt of energy is supplied. So these wavelengths associated with 4 electron volt, right? Okay. So whether this is sufficient or not. So this is the energy supplied. So now for metal one, what is the threshold energy or the work function? It is given 4.8, but this wavelength is associated only with 4 electron volt. So this wavelength is not sufficient. For the metal, for the first metal M1, how much is the threshold frequency, threshold energy or the work function? It is having 4.8. So if this value, if this value is also 4.8, if this wavelength also associated with either 4.8 or more than that, then only photoelectric effect can be seen in the metal 1. Okay, but it is having 4.8, it is having only 4. So it means in this first one, photoelectric effect cannot be seen because the value of work function is more than the value of the supplied or incident wavelength or incident energy. Okay, so for second one also it is 4.3, which is greater than this. So here also we cannot see. Okay, and the next one, let us see. Let us look here. What about this? So there also it won't happen now. Only in metal 4 we can expect because it is the lesser than the threshold frequency, lesser than this. See, the value is this 4 electron volt. So this 310 nanometers is there now. So this wavelength will be having 4 electron volts of energy, which is greater than this its threshold energy or the work function of that particular metal. So which metal it is showing? M4 is a metal showing this photoelectric effect. Okay, so this is how you can do this question. I mean, see, the concept is easy only, but I'm trying to explain this from very basic manner. That's what the new students also can able to follow. That is my only intention. But we can solve this question within seconds only. Okay, but I just wanted to make everyone clear that what exactly photoelectric effect is. Okay, if you are still not clear, so you can rewatch it or you can read from any of the basic textbook, either physics or chemistry, that can be gives you more clear idea. So which metal is showing out of this M1, M2, M3 and M4? Only fourth metal is showing, and first 3 metals are not showing this photoelectric effect. They are also asking metals which do not show. So which metals will do not show? M1, M2, M3 will not show this photoelectric effect. So that is what M1, M2, M3 are not showing. Okay, M4 can show. Okay, I hope it is clear how to do this photoelectric effect based questions. Okay, in the second period of modern periodic table, the 2 elements X and Y have higher first ionization enthalpies values than the preceding and succeeding elements. Okay, so X and Y are the, see, from the given 4 options, he is saying that 2 elements out of this 2 element, a pair of X and Y, we need to find what is X and what is Y element. Okay, which are having ionization energy greater than the element which is preceding and succeeding to it. It means, for example, here I am taking, for example, here if I say nitrogen is there, so for nitrogen ionization energy, so what are the preceding and succeeding elements? Here we have, before this we have carbon and here we have oxygen. So when we compare with the ionization energy of carbon and nitrogen, nitrogen only will be having higher ionization energy. Similarly, this side also oxygen and nitrogen only having higher energy. So why it is? Because of its half filled configuration, right? So that's why nitrogen is more. Okay, second period they told, so that's why second period element I have taken. So now nitrogen is one of the element which is obeying or which is satisfying this statement. And in the second period, what are the other elements we have? Lithium, beryllium, boron. Okay, then next carbon, nitrogen, like this now. Okay, so here again if you compare beryllium, lithium and boron, so here also beryllium will be having more ionization energy than this lithium, as well as beryllium is having more ionization energy than this boron. So what is the reason here? Because of the 2s2 electronic configuration of beryllium. So these s electrons will be strongly hold to the nucleus due to its high penetrating capacity when we compare with the boron and lithium. So here it is having 2s2 2p1. So it is relatively easier to remove electron from 2p orbital than this 2s2 orbital. Okay, that's why beryllium is having more ionization energy. So beryllium, nitrogen are the best suitable answers from here. Okay, I hope it is clear. Again, see, we can directly, by looking at the question itself, we can directly remove two options from here. So this I am removing, this I am removing. Why I am removing? Because these are not second period elements. No? Sodium, aluminum, sulfur belongs to which group? So these are what? Third period. No? Which period? Third period elements. They are saying second period. So easily we can eliminate these two. Okay. So now we need to segregate our answer from only these two things. No? So it is easy by comparing the values. Hope it is clear. No confusions, right? Okay. Let's move further. So anyone in online? Okay, let's move. Consider the following pair of elements and consider the following pair of elements and identify the pair of elements with which have nearly same atomic radius. Okay, so how do we do this? So now these elements are from D block, right? So like lanthanum, yttrium we have, and zirconium, hafnium here we have, molybdenum, tungsten here we have, so chromium, molybdenum we have. So how can we do this? So this is based on the lanthanide contraction. So what is that? Lanthanide contraction. So based on that, we know zirconium and hafnium having similar sizes. Now similar sizes. So if we take 3D, 4D, 5D, 6D series elements, okay, so we know more than this 3D, 4D elements having larger size. Okay, so size increases as we move down the group. So 4D will be having more size, but when it comes to 4D and 5D, so due to lanthanide contraction, they will be having similar size. The elements from 4D, 5D series will be having similar size. So zirconium and the bottom of it we have hafnium. So both of them have, one is from 4D series, another is from 5D series. So they have similar size. So I can go with this. So again, along with these options, these are also belongs to 4D, 5D series elements now, 4D, 5D. So they will also be having similar sizes, okay, or same atomic radius, okay. So I can choose 2 and 3. 2 and 3 is the best answer for this, okay. So you will be studying about this in the D block, okay. So every student might be who are preparing for even boards, they will be coming across these kind of statements, okay, due to lanthanide contraction and all, right. Okay, let's move further. Okay, here identify the molecule or ion in which the ratio of sigma to pi bonds is 3:2. So how can we do this? This is also easy question here. So in the first option, what we have here? Carbonate. Okay, write the structure of that carbonate, O minus. Okay, identify the molecule or ion in which ratio of sigma pi bonds. Okay, so now OH means here also one sigma bond. Now count the number of sigma bonds in this. 1, 2, 3, 4. 4 sigma bonds. And how many pi bonds are there? 1 pi bond. 1 pi bond. So it is 4:1. Let us go for this option. Okay, so I am writing C H H C C triple bond N. Triple bond N, that's it. So number of sigma bonds you count here. For this, sigma bonds are 1, 2, 3, 4, 5, 6. 6 sigma bonds. And how many pi bonds are there? Pi bonds are 1 and 2. Once again, 1, 2, 3, 4. So 4 pi bonds are there. So it is 6/4. So I can also write it as 3/2. So option 2 is satisfying the given condition. Given ratio is satisfied by option 2. So you can take option 2 as your answer. Okay. So for HClO4, it won't be satisfied. So you can look into its structure once. So if we write it like this, so there are how many sigma bonds here we have? So 1, 2, 3, 1, 2, 3, 4 sigma bonds, and pi bonds how many? 1, 2, 3. 3 pi bonds. So it is 4 by 3. So that is not satisfied by 4. Even by this one also it won't be satisfied, because there will be 3 sigma bonds and there will be 3 pi bonds. You will be getting 1 as the answer for this. Okay. So only option 2 is most accurate answer here. Option 2 is correct for this. Okay. Next, here a flask at 298 Kelvin, a flask A of unknown volume V here, V, okay, unknown volume V, contains oxygen at 5 atm. So what is the pressure they mentioned? Pressure is 5 atm mentioned. Okay. Another flask B, this is about A I am writing here, another flask B, okay, of volume 2 liter, contains helium of 3 atm. Okay. The two flasks are connected together by a small tube of 0 volume. Okay. The volume of that small tube is neglected here, they are saying. Okay. After two gases are completely mixed, if the resulting mixture is found to have a mole fraction of oxygen as, okay. So this contains what? O2, this contains helium. So both are getting mixed. So both are like helium is inert gas, therefore it won't react with the oxygen. So they just mixed. Okay, no reaction between them. Okay. Now mole fraction of oxygen is how much they mentioned? Mole fraction of oxygen is mentioned as 0.2. So sum of mole fractions of all the gases will be equals to 1. So what are the gases here they mentioned? Oxygen and helium. So mole fraction of helium plus mole fraction of oxygen will be equals to 1. This is the sum, total sum, right? So we need mole fraction of helium, that is 1 minus 0.2. So I am writing 0.8. So mole fraction of helium will be 0.8. Okay. See guys, here I will be explaining you with each and every step. Therefore you can like even if you are listening for the first time, you can able to understand it. Okay. So we can do this in the faster manner also, but that will not be like useful for some students. Okay. So because they might not be understand. Okay. So let me give this basic explanation also, therefore it gives you more clear idea. Okay. Now what is the ideal gas equation we have? PV equals to nRT. Here the mentioned temperature as 298 Kelvin. So temperature is constant now, universal gas constant, R is also constant now. Okay. Now in the question they are asking about volume of flask A. Okay. So which means we need to find this VO2, volume of O2 we need to find here, or volume of flask A they are saying na, let us write VA only. Okay. So what I can write? P1 V1 from this, P1 V1 by N1 equals to P2 V2 by N2 I am using. This is the formula I am using here. Okay. So let me change the color, the pen. Okay. So what is the P1 they mentioned? P1 they mentioned is 5. Okay. And V we need to find, V I am writing. And how many moles they mentioned? See, moles they haven't mentioned, but mole fraction they mentioned. So what is the mole fraction formula? So N, see for mole fraction of O2 means NO2 by N total we have to write. Okay. Similarly, mole fraction of helium means I should write N helium by N total I should write. Okay. If I take the ratio of these two, so I can cancel out this N total and N total. So we can write this mole fraction ratio which is equals to number of moles of O2 by number of moles of helium. Like this also we can write. So I am sending this N1 to this side, therefore it will become N1 by N2. So N1 by N2 is nothing but, so N1 is how much? This is 0.2 I can directly take, because they are also equals to ratio of mole fractions of that gases now. So that will becomes what? N1 by N2. I will be writing, wait for some time. Okay. Then next what we have here? So P2. So P2 is how much they mentioned? It is 3 atm. Okay. And V2 is how much they given? So 2 liters. Okay. And what is N1 here? N1 by N2 means N1 is 0.2 and N2 is 0.8. That's it. We are almost done with the question. Okay. So now we need to find this volume of A. So VA equals to, Va equals to, so this will become 4 times, okay, and this will becomes 2 times, okay. So now what we are having, 3 by 2 into this 5, so 3 by 10 we have, 3 by 10 means 0.3, so 0.3, do we have 0.3 or not? Let us check. Yes, 0.3 is our answer. I hope it is clear how we did this question, right? So just ideal gas equation based questions, okay. Then next let us move further. Which of the following oxidation state of nitrogen is lowest, okay, it should be very least value. So in this case we have nitrogen surrounded with 3 hydrogens and 1 oxygen, so oxygen will be -2, okay, 2 hydrogens will be, 4 hydrogens means +4, so +4 hydrogens, it means this will be nitrogen is -2, also oxygen is -2, 2 hydrogen +4, that's it. It is nitrogen is having -2 charge in the first case, okay. In the second case, here 4 hydrogens are there, so +4 for hydrogens, and chlorine is there, -1 for 1 chlorine, okay, and remaining -3 will be on the nitrogen. It means in the first case it is -2, in the second case it is -3. So this is the least value out of first and 2, and here 2 nitrogens are there, 4 hydrogens are there, okay. It means what we can say, so -2 for each of the nitrogen, okay. So this is also lesser than this, okay. In the fourth case, HNO2 means oxygen will be, 1 oxygen will be -2, 2 oxygens are there, so -4, so 1 H plus is there, so 1 plus means still remaining +3 is required, therefore oxidation state here is a +3. So which is small value here, -3 is the smallest value, now that's why option 2 is correct. If they are asking about highest value, you can go with fourth option, okay. I hope it is clear. Least value is this one, highest value is the option 4, which is +3, okay. Hope it is clear now. Least value they are asking, so go with option number 2, okay. Next, which of the following are processes are reversible, okay. So now vaporization of a liquid at its boiling point, yes, at boiling point, so vapor and its liquid will be in equilibrium, so that reversibility is possible in that case. Similarly transformation of solid substance into liquid at its melting point, here also solid and liquid will be in their equilibrium state, so here also reversibility is possible. So 1, 3 is okay. Next let us see option 2, expansion of gas into vacuum. See, vacuum means the pressure will be 0, external, that pressure in the vacuum will be 0, so free expansion takes place. So whenever it is free expansion means no external force, so there is no reversibility, right. So it is a one side process, okay. So I can say no reversibility in second option, okay. And the next, neutralization of acid base neutralization, generally they are irreversible reactions, so the reversible processes here is 1 and 3 only, other things are not the reversible, only 1 and 3 is correct for this question. Next, this is again interesting. This question is based on simultaneous solubility. What is that simultaneous solubility? Let us see. So magnesium carbonate, silver carbonate is given, saturated solution of these two things are given. If the concentration of magnesium plus 2 is given like this, then the concentration of Ag plus, so from this Ag plus concentration is how much they are asking. So Ksp of both salts is given, so we need to find Ag plus concentration. Very easy, look into my explanation, that will be more useful here, okay. I think this pen color is visible, right? If there is any difficulties, you can write in the comment box. So magnesium carbonate, so saturated solution means it exists in equilibrium with its ions. So Mg plus 2 plus CO3 2 minus, like this we can write. And similarly we can write for silver salt also, Ag2CO3, okay, silver carbonate. So this will be having Ag plus 2 silver ions, so 2Ag plus CO3 2 minus. You have to write it like this. So Ksp for this you should write in this manner. So Ksp equals to concentration of Mg plus ion, Mg plus 2, and concentration of carbonate ion 2 by MgCO3. So since it is a solid species here, saturated solution, so we cannot, no need to worry about this one, okay. So here also Ksp of Ag2CO3 will be concentration of Ag plus to the power of its coefficient, that is 2, and concentration of CO3 2 minus. Like this we should write. I hope up to here it is clear. So now KSP, they are given the KSP of this one, both salts KSP is given. So concentration of magnesium ion also given. They are just asking this Ag plus ion concentration. No? Let us say this equation 1, this is equation 2. So now take equation 1 by 2. So KSP of MgCO3. Okay, look here very carefully, this is interesting thing here. KSP of Ag2CO3. This, if you understand it properly, then you can do all the things from this particular equation. So Mg plus 2 concentration into carbonate ion concentration, okay, by Ag plus square into concentration CO3 minus 2. Okay, this is what we need to take here. So this carbonate ion is removed here. So what is the concentration of Mg plus 2 mentioned here? So from these I can write KSP of MgCO3 how much? MgCO3 is how much they mentioned? 1.6 into 10 power minus 6. So I can write it as 16 into 10 power minus 7. Just for calculation purpose only I am writing like that. Okay. Next, here 8 into 10 power minus 12. Okay, whatever the data they given I am writing here. Okay, then next, what is the concentration of magnesium given? So magnesium is this is 3.2 into 10 power 5, 3.2. So I am writing 32 into 10 power minus 5 is there, so I am writing minus 6. Okay, and now we need to find for Ag plus 2. I hope this is clear how I am writing this equation. See, this is what we need to find in the denominator, right? So look here, simple calculation this is. So now I am removing this 2 times, okay, and these 2, and here it is 16, okay. I hope up to here it is no confusion. Okay, no confusion, nothing. Okay, after this 10 power minus 12 is there, 10 power minus 7 is there. So I can write here 10 power minus 5 is still remaining here, right? Okay, so in the denominator we have 10 power minus 5 here, and here we have 10 power minus 6. Okay, so from these, what are the remaining things I am writing over here? Okay, so Ag plus 2, Ag plus square, which is equals to, so if I send this side and I am sending this side, 16 into 10 power minus 6, and this is minus 5. So how much it is? Minus 11 I am writing. Okay, so up to here it is also clear now. Okay, so after this what I am doing is, so in order to make this more clear depending upon the options, so I just want to convert into options format. Okay, so I am taking this as Ag plus square equals to 1.6 into 10 power minus 10 I am writing. Okay, so we can write this in this format, right? So now by sending this 2 from here to here, it will become root 1.6 into 10 power minus 5. So we have option number 4, root 1.6 into 10 power minus 5. I hope it is clear without any confusions. Okay, so even I am moving back, so you can just take a screenshot of it. Okay, so this kind of questions are also interesting, and you will be seeing in this kind of questions in JEE mains and in the EAPCET here this time. Okay, next, temperature of so this will be for water, the temperature of maximum density of water is Y, and for D2O is X. So generally for water it will be considered to be 4 at 4 degrees, and for deuterium heavy water it is around 11. Okay, now the difference will be around 4 minus 11. Okay, so this 11 minus 4, so this will be around 7 only. As per the options it will be around 7. Okay, 7.6. there will be some decimal numbers also, but exact value, if we go with the options, you can go with option number 1. Okay, then next, how many of the following metals give oxides and nitrates? So as per me, here oxides will be formed by most of these like metals, but nitrates are formed only by few. So as per me, I am going with option magnesium will be forming nitrates as well as lithium. Only this will be the suitable metals which are forming nitrates and oxides both. Okay, so my option is 2, but here it is given as 5. So let us look into it. So whether if any changes are there, you can write in the comment box if you know, or otherwise we will discuss about this later. Okay. Then next, identify the correct incorrect order again is the property of given in the bracket. Okay. So see, carbonates is given, sulfates is given. So now tell me, what about carbonate stability? See, carbonate ion is large in size now. Okay. Now the metal which is having like large size cation, large size anion, so the resulting compound will be more stable. You can remember like this. Okay. So large size cation can be stabilized by large size anion. You can remember like this. So therefore, down the group size of cations increases for first group elements and second group elements, first group metals and second group metals. So carbonate stability down the group, carbonate bicarbonate stability down the group increases. Okay. So it means in the second group elements which is more stable, strontium carbonate is more stable. Yes, the order is correct only. They are asking about incorrect order. Okay. So first order is correct only, but we need to choose incorrect one. So second order, see here, solubility. Solubility, what happens here is, so this is also correct, solubility also. And when it comes to lithium, see, first group element carbonates, what I told you, so carbonate stability down the group cation size increases, so large size anion, carbonate anion is large in size now, so that will be stabilized by large size cation. Okay. It means down the group stability of carbonates increases for first and second group elements, but it is given as decreasing for this first group element. So which means this is the wrong or incorrect order as per mentioned. Okay. You can take the option 3 as your answer. I hope it is also clear, right? Next, diborane. So diborane upon hydrolysis gives a compound X, that is orthoboric acid is formed. See, on diborane we have made a special video of 10 minutes, just 10 minutes in the golden minute series, where I have covered many things regarding like all the important things regarding this diborane. So in this EAPCET, Telangana EAPCET, I have seen I think 2 or 3 questions on diborane, and those questions are purely covered in the 10 minutes of topic. So you can go through the playlist and you can watch diborane concept completely for more clarity. Okay, after watching this session. Okay, so diborane upon hydrolysis gives orthoboric acid. Okay, this X is orthoboric acid. It means formula is H3BO3. Okay, this is our X. Okay, the correct statement about this. Okay, it is a tribasic acid. No, it is a monobasic acid. It will be having structure like this. Okay, so it won't have any acidic hydrogen, just it can accept a lone pair electrons like an Lewis acid and show its acidic nature. So it is a weak monobasic acid. So it is a weak monobasic acid, or you can also say it is a Lewis acid. It has a structured layer like structure. They are asking correct statement. The layer structure. Okay, it is sparingly soluble. Okay, it is not completely soluble, it is sparingly soluble. So out of this 2 and 3, so 2 and 3 are only the correct statements as per the data provided here. Okay, so you can go with option number 2, which is having 2 and 3. Next, graphite has structured layer like structure. Yes, layers will be there, that's why it is having lubricant applications. We will be seeing as a lubricant. Graphite show its like lubricant activity because of the layer structure. Okay, one layer will be the above the other, like that will be having. Okay, Buckminster fullerene is not aromatic in, no, it is aromatic in nature. They are asking about correct, choose the correct statements. First one is correct, second one is incorrect. Distance between the two adjacent layers in the graphite is not 441. No, this is also incorrect. Okay, so the hybridization of carbon in graphite and Buckminster fullerene is sp2 only. So both is this one is correct. 1 and 4 is correct. 1 and 4 is correct. Okay, fullerene, Buckminster fullerene is aromatic. It's given as not aromatic, but it is aromatic actually. Okay, so 1 and 4 only correct options. Which of the following is a lung irritant that can lead to acute respiratory disease? So you can go with option number 4, NO2. Okay, next, arrange the following in the decreasing order of boiling points. So now given 4 compounds, so we know for hydrocarbons, as size increases, I mean as molecular weight increases, the boiling point increases. Okay, it means for a hexane will be more than this pentane because it is having 6 carbons, it is having 5 carbons only. So D is having max. Okay, after D we have B, C here. So here we have 2 dimethyl propane. It means how many carbons? 1 2 3 4 5. So here it is N pentane. This is like straight chain pentane. This is branched 5-membered compound, and here it is branched 4-membered compound. So which is more having more boiling point? So one is having more because straight chain, long chain it is. So D is more. After this, out of A, B and C, how can we decide? See, this is a straight chain. Straight chain will be having like strong intermolecular forces between the compounds with the surface area. It will be having more surface area. So more the surface area it will be having, more boiling point it will be having. So that will be having, showing. So pentane will be covering more surface area, right? So that's why pentane is having more boiling point than this 2-methyl butane and this 2, 2 dimethyl propane. Okay. So D, next C. Out of these two, like straight chain number is more here, straight chain is more here when compared with B. So that's why A is more than B. So D, C, A, B is the answer. D, C, A, B. That is what the second option here. Next, fast. Next, here which of the following ring is not aromatic? Look here, aromatic means should contain sp2 or sp hybridization, planar, cyclic compound. All these conditions we have seen now. So here you can see the first option, this is sp3 carbon, which does not have complete planar structure, right? sp3 means tetrahedral geometry it will be having and complete conjugation is also not present. Therefore option 1 is non-aromatic we can say. So whereas option 2 is aromatic, 3 also aromatic, 4 also aromatic. Okay, they are asking non-aromatic, not an aromatic. First one is the correct one. Next, which are the following is least stable carbocation? So which is least stable? See, this allylic can be stabilized by lone these pi bond electrons, right? And this phenyl ring is attached to this carbocation. So this we should call it as benzyl carbocation, and this is allyl carbocation. Both are highly stabilized by mesomeric effects. Okay, and here we have methyl group attached to the sp2 hybridized or the carbocation which is having empty orbital. That empty orbital, the alpha CH sigma electrons will be donated from this methyl group. Therefore it will be having 3 hyperconjugative structures which is stabilized by 3 hyperconjugations, and we can also say this is inductive effect. Okay, so plus I effect. That's how 1 is stabilized as well as 3, 4 is also stabilized. So here sp2, whenever we have carbocation or carbon anion sp2 carbon, I mean double bonded carbon, directly attached double bonded carbon or triple bond carbon, those are highly unstable. Okay, so this kind of compounds, like this kind of systems are called vinyl carbocations with positive charge vinyl carbocations, and anion means negative charge vinyl carbon anions. So these are highly unstable because of this sp2 carbon with which is highly electronegative, again with positive charge it makes more destabilized. Okay, so second option is correct for this. Okay, if I wanted to ask you the order, what is your order of the stability? So how can we write? So first one is least stable. After this one first, I mean the second option, this is the least stable. After this one. Okay, and out of these two, this is stabilized more number of times because phenyl ring is there, benzene ring will be attached to this, so more number of resonating structure. This is highly stable, and after this is little stable. See, this is highly stable, then after this one, okay, and after this one, and these are least stable. Okay, so what is the order? So more stable is 4, after that 3, 1, 2. This is how you can arrange them in the order of increasing decreasing stabilities. Okay, so the incorrect statement about Schottky defect. So Schottky defect and Frankel defect, these are the two defects we have in solid state we will be studying. So Schottky means what happens? See, Frankel means so the ions will lose their original site and they will occupy some interstitial site, right? So Schottky defect means what happens? So they will like one cation and one anion, or equal number of positive and negatively charged species will miss from their lattice site, right? So it is due to missing of equal number of cations and anions from their lattice site. Okay, this is correct statement only. They are asking about incorrect. Okay, next the on the whole crystal is electrically neutral. This is also correct because same number of cations and anions are missing from the lattice. Okay, next it is shown by ionic compounds in which cation and anion are of almost same size. Yes, this is also correct. And last statement, density of cation crystal increases. See, when cation and anion are missing, see, it should have some mass, right? See, what is the density formula? Mass by volume. See, if two species are missing, it means two ion particles are missing, means weight will decrease. Na? If weight decreases, density also decreases. Therefore, density of ion like crystal decreases, but they told it as increases. So option D is incorrect. So you can choose the incorrect one is fourth one as your answer. I hope it is also clear, right? Let us move further. Again, this is from Raoult's law here. So two liquids AB forming. So let me check once. Anyone in the comment box writing anything? No. Okay, fine. Two liquids AB form an ideal solution at 300 Kelvin. The vapor pressure of solution containing 1 mole of A and 3 mole of B is 550. At the same temperature, if one more mole of B is added to the solution, the vapor pressure of solution increases to 560. Then the ratio of vapor pressures of A and B in their pure state. A simple question it is. Let us do this here. Okay, so here I am taking, okay, so what is the Raoult's law we have for ideal solutions? Raoult's law, P total or P solution, vapor pressure of solution equals to vapor pressure of component A and vapor pressure of component B in the solution. Okay, like this we can write. Again, when we wanted to write this like vapor pressure of component A in the solution, I can write vapor pressure of component A in its pure state and mole fraction of that particular component in the solution plus P naught B chi B. This is how we can write it. Okay. After writing this, two liquids AB forms an ideal solution at 300 Kelvin. The vapor pressure of a solution containing 1 mole of A. Okay. So 1 mole of A, and see, total pressure is how much? 550 I am writing. Okay, containing A and B is, see, here I am writing P naught A as it is. This is what we need to find, the ratio we need to find. Okay, so chi A means what? Mole fraction of A, means number of moles of A by total number of moles. Number of moles of A is how much? 1. So write 1 by total number of moles 1 plus 3. I am writing 4 here. That's it. And next P naught B is how much? We need to get that value also. Okay, P naught B. And chi B means what? Total number of moles are 4 and 3 is the number of moles of B we have. So this is equation 1, let us say. Okay. Now equation 2, what they are saying? So if 1 more mole of B is added, so 1 more mole of B is added, therefore total pressure is becoming 560. So as per the data mentioned. Okay. Now P naught A I am writing, that will be P naught A, vapor pressure of A in its pure state will be same only. Okay. So total number of moles, now how many it will become? 1 more mole of B is added. So A is remains same, number of moles are A of A is same, but total number of moles becoming 5 here because 1 more new mole of B is added. So here I am writing P naught B, here in the denominator 5, in the numerator it will become 4. So this is equation 2, let us say. Okay. So now from this, what we can write from these two? Okay, so here I am writing first one I am writing 550 equals to P naught A plus 3 P naught B by 4. So I am writing here 4, this by 4 means here I am writing. Okay. Similarly, this will be 5 into 560 equals to P naught A plus 4 P naught B. Okay. So like this we can write. So you can simplify this. Okay, 5 are 5 11s are 4s are 14s are. So like this you can simplify. So finally you will be getting a ratio of 2:3. If you simplify this, you will be getting the ratio of P naught A to P naught B as 2:3. So this is your final answer. Okay. Okay. So I hope it is clear how we can simplify that. Next. This is simple question again. I will be giving you the like direct some explanation about this. You can do. Molar conductivity of acetic acid at infinite dilution is this much. Okay. What is the molar conductivity of 0.01 molar acetic acid is? Okay. The molar conductivity. Okay. So this is the limiting molar conductivity. So not M of acetic acid is 390. This is given. Okay. So they are asking at what is the limiting molar conductivity. It means, so they are asking limiting molar conductivity means at some x, so at this concentration what is its conductivity. So this is what we need to find. So for finding that we have Ka now. So from that Ka we need to find alpha. So alpha relates these two things as molar conductivity at concentration at some M concentration and limiting molar conductivity. This is the relation between the alpha and this thing. So if we know this alpha, already we know this, we need to get this alpha, therefore we can find this final value. Okay. So how can we get this alpha? From Ostwald dilution principle, what we have, alpha equals to root over Ka by C, that's it. Okay. Ka value is given here and C value also given here. So from that you can get the alpha value, you can substitute here and you can multiply with this and you will get the final answer. So there will be an option from this 4. Okay, you can choose that. Hope it is also clear how can we do this. Okay, next, half life of a zero order reaction A to B is given. Okay, the initial concentration of A is 4. How much time does it take for its concentration to come from 4 to, okay, so simple again, half life is given. So T half. So what is the formula of T half for zero order? So T half of zero order equals to 0.693 by K. So this is what we need to write for first one, and the next what they are, how much time does it take for its concentration to come from that one to this much. So from here to here conversion, how much time it will take. So you can take T equals to 1 by K. Okay. So here you can write log, instead of that you can write 2.303 log initial concentration is A naught by concentration into time T. This is what the formula we need to use here. So we need to find the time it required for this conversion. So T equals to 2.303, okay, and log. So what is the initial concentration? They told 2, right? So 2 by final concentration 1. This is what I can take here. And what about K here? So K we can get it from the half life order. So that is 0.693 by T half, that is 0.5. So it means 1 by 2 I am writing, 1 into 2 I am writing here. So here also it is 0.693, okay, by 2 means I am writing here multiplied with 2. Okay. So this log 2, 2.302 and okay, and what we can say, okay, okay. So log 2 means, okay, wait, 2.303 log 2, A naught is 2 log 2 and 1, okay, that is fine. So this can be removed as how many times? So this is, okay, log 2, so we are getting T as 1 by 4, right? Okay, let us check once again. So 2.303 by K, K is how much? 0.693 by K, K means, okay, 0.5 by 2, okay, 1 by 2, 2 is there, okay, we take for concentration, okay, 0.5. Okay, T half is given, so T equals to 2.303, K is, K means 0.693 by 2, okay, 2 means I can write into 2, log A naught, A naught concentration is 2 and A minus X is 1, okay. So log 2 means we can write 2.303 T03 into 2 into 0.3. Okay, this one is fine by 0.693. Okay, so how we got this 0.693 means, so T half, it means 2.303 K log A by 2. So this it will be A by 2 means log 2 means 2.303 by K log 2. So here also we have log 2 0.303. Okay, K 0.603. Okay, so we are getting this value as T half equals to, so okay fine, we are getting answer it as 2 hours, but it is not there in the options. We'll see this question. Let us remember this question number 144. At the end of the session we will do once again. If any confusion in our, we will be rectifying it, or we'll check whether their answer is correct or not. Okay, so now next, what about this? So we have solution, we have to match it. Okay, so here foam is there, gel is there, aerosol is there. So foam means what? So foam, paint, gel, aerosol. Okay, this is from surface chemistry, we will be studying this. So what exactly here? Okay, so gel means what? We will be generally taking example as butter or curd, right? So C4, okay, C4, and then next foam is what? Wiped cream is foam. So B2, so C4, B2, C4, C4, B2, yes. So third option is correct now. So this is based on the like general example which are there in the NCERT or your Telugu Academy book only. Okay, I hope it is clear how we are matching it. Next. Observe the following. The choice of reducing agent for reduction of an oxide ore can be predicted by using Ellingham diagram. Yes, that is correct only. By a plot of delta G naught versus T. Yes. Okay. According to Ellingham diagram, the metal oxide with higher delta G naught is more stable than the oxide with lower delta G naught. How can we say this? According to Ellingham diagram, metal oxide with higher delta G naught is more stable than the oxide with lower delta G naught. Yes, this is also correct only now. Metal oxide with higher delta, see, more negative it should be. So it is higher delta G naught. It is higher negative. So it means according to Ellingham diagram, the metal oxide with higher delta G naught is more stable than the oxide with lower delta G naught. No, this is a reverse we can say. The metal oxide with lower delta G naught is more stable than the oxide with lower delta G naught. So this second statement is incorrect and first statement is correct. Okay, so we know for a system to be more stable, so what we can say, that energy should be less. So but here they are saying Gibbs free energy should be maximum. Higher means energy is lower, I mean stability is lower. Higher energy, lower stability. So this is second statement is incorrect. It should be reversed, but they given in other format. So statement 2 is incorrect, statement 1 is correct. So where do we have like that? Statement 1 is correct, but statement 2 is not correct. You can go with option number 2. Hope it is clear. Let us move further. 1 is correct, 2 is incorrect, right? So 147. Which one of the following order is correctly matched with the property mentioned against? Yes. So see here, boiling point. So again, same question we have seen in the some other paper also. Some medical, I mean BPC student, agriculture and pharmacy paper also I have seen one application based question on this hydrates. Okay. So now in that what we know, boiling point of water is more than this any other thing in the hydrates. Why? Because of its intermolecular hydrogen bonding only present in water hydrates. I mean water only, H2O, oxygen hydrate, H2O only, not in the other case. It should be maximum, but it is given here, so this order is incorrect. Now now oxides of nitrogen if we consider, so this order is correct only. Why it is correct means, so nitrogen central atom is same, so with increase in oxidation state, what I am saying, with increase in oxidation state, for these electronegative atoms, with increase in oxidation state, here it is plus 5, it is plus 4, it is plus 3, plus 2, 1. Okay, with increase in oxidation state, their acidic nature also increases. So this is a statement you can remember. Okay, so now this order is correct only. Now for what about this acidic acid, like acidic nature of these compounds? So down the group for hydrogen halides of, say, like hydrogen halides, down the group the acidic nature increases and stability decreases. So which is more acidic in this case? HI is more acidic, but they given in the reverse order, which is false. Okay, you can remove that. Okay, the bond angle, see in the bond angle case, only bond angle will be measuring accurately from H2O, and for remaining hydrates, that will be around 91, 92 like that, but for water it is 104. So water will be having highest than any of these hydrates, so it should be max, but this is also incorrect. So you can remove this, okay, because again we will study that there is no hybridization in H2S and H2SE. Okay, so based on that the bond angles are around 90, 91 degrees like that, but for water it is 104. So this fourth option also incorrect. So what is the most accurate one? Second option is correct. So you can go with second option. Okay. Here, this is about applications. We'll study in Henry's law. Noble gas X is used as a diluent for oxygen in modern diving apparatus, and noble gas Y is used mainly to provide inert atmosphere. Okay. In high temperature metallurgical processes, what are X and Y? See, in order to create this inert atmosphere, we need a inert gas. Okay, so inert gas means, yes, all of these are inert gases only. Again one more thing, diluent. So here diluent is what? In order to make a scuba diver will bring the oxygen cylinders along with them to while doing their diving. Okay, so there they will dilute the oxygen with some X. That X is what? Argon gas here, and helium gas is used to create inert atmosphere. So you can go with option number 2. Okay, next, the dibasic oxoacid of phosphorus. So that we can expect dibasic oxoacid which undergoes disproportionation. It means that phosphorus acid should contain intermediate oxidation state, like phosphorus can show maximum of +5, it can show maximum of +5, okay, and it can go to the remaining lower values. Okay, so it has intermediate oxidation state, let us say +3. So now I am taking the oxoacids of phosphorus, dibasic acid they mentioned. So this is the best example for dibasic orthophosphorus acid. It is called as orthophosphorus acid, which is an oxoacid which is having dibasic. It means it releases 2 H+ ions from this. Okay, so now +3, now it can undergo oxidation and become +5, which is H, what they are saying, to give 2 products. Okay, so it can form this +5 oxidation state H3PO4, which is orthophosphoric acid. This is orthophosphorus acid. Now it can go to the lower oxidation state, so like PH3 is formed. When it is phosphorus acid undergoing disproportionation reaction, we can get phosphine and we can get orthophosphoric acid. So these are the 2 options we have. So option number 3 is correct for this question. Let's move further. Okay, the number of moles of oxalic acid, oxalate ions oxidized by 1 mole of permanganate ions. So how can we do this? So oxalate ions, so I am taking C2O4 minus 2. Okay, so these I am treating this with KMNO4 when we are treating with permanganate. Okay, permanganate they are saying. Okay, so this CO2 can be oxidized, C2O4 can be oxidized to CO2. So 2 moles of CO2 will be evolved, and here manganic acidic medium that will be converted into +2. So from +7 to +2 conversion takes place in acidic medium. So no need to worry about the balancing the equation and all. It is very simple here. So number of oxalate ions. So I am taking N is the number of moles of oxalate ions. Okay. So now from CO2 to Cn. So from here to here it is converting. Here oxidation state is +3. Here oxidation state is +4. Okay. So +3 to +4 means how many electrons is involved here? So 1 electron for 1 carbon, and how many are there? 2 carbons are there. 2 into 1. So 2 electrons are involved. So N factor for oxalate will be 2 here. That is what the number here I have written. So that will be equals to, now KMNO4. So by 1 mole they are saying number of moles of KMNO4 is 1. Okay, and what is its N factor? So its N factor is 5. So manganese ion is 1. Okay, so +7 is converting to +2. It means +7 reduced to +2 means how many electrons involved during that process? 5 involved. So take it 5. So N can be becoming 5 by 2. So I can write it as 2.5. So this is our answer, which is option number 1. Hope it is also clear now. Let us move further. Okay, So total number of geometrical isomers possible for the complex. So these are the complexes given which will show geometrical isomerism. So this is having tetrahedral geometry. So in tetrahedral geometry, geometrical isomerism is not exist, won't exist. So okay, remove that. Okay, so now this is octahedral geometry. Yes, here it can be existed. So now these two chlorine atoms I can place opposite to each other at 180 degrees, so that it will become trans, and I can keep 90 to each other, so it will give cis. So cis trans isomerism exists in this one, and here also three are there. So this is Ma3B3 type. Ma3B3 means we have two types of isomers, geometrical isomer. One is facial, another one is meridional. So this is also possible. So here 5 are there, so it is not possible. At least 2 should be different. Okay, so it can be possible from M, like ligands should be of 4-2 type, like first one type, but 5-1 it won't exist. Okay, so here nickel again tetrahedral, it won't be exist, it won't show. Again here 4-2, it means it can show the geometrical isomerism. Okay, so this is nothing but the first option only. Okay, next here we have Ma3B3. Yes, this can also shows, and here you can see. Okay, fine. This is in the Telugu question, I think so. That's it. Okay, so now what are the options showing geometrical isomerism? So this one, only 1, 2. So 2 isomers only, 2 compounds only showing geometrical isomerism or what? Let me see. Total number of geometrical isomers possible for the complex. Yes, this is not showing, this is also not showing. Only 2 are showing here. Out of these 4, only 2 are showing here. So but they have given option as 3, which is mentioned it as 4. That is absolutely incorrect, because geometrical isomerism exists, cis trans isomerism exists in these 2 complexes only. So you can go with option 1, not with 3. Okay, so I hope it is clear why I am saying that. So here option 4 is answer 4 is incorrect. You can go with option number 1, that is 2 isomers, 2 compounds only will show. Okay, wait. What is the question? Total number of geometrical isomers possible for the complex. Yes, it won't show. Let me do this once again. Total number of geometrical isomers possible. So this is will not show. This is also won't show. That is clear for us. Okay, now this will be showing, one is cis, another one is trans. Okay, this will also be showing, one is facial I told you, and another one is meridional I told you. Okay, so total number of isomers are how many? Yeah, this is what their question. Total number of geometrical isomers possible for the complexes. Yes, so they won't show. Here it will show 2, and here also it will show 2. So total 4. Yes, this is the correct one. Yes, their option is also correct. So you should not confuse that. When we read that, first time I felt that how many compounds will show geometrical isomerism. That is not the question here. How many isomers are exist here? Total number of geometrical isomers possible here. So those are 4. Here cis trans, here facial and meridional. So those are the 4 correct. Okay, so you can go with option number 3, which is 4. It's correct only. Next, so this is just based on these polymers. Okay, so you can just give a try from your side. Like see, here we have PVC, like vinyl chloride they have taken. So this will be forming polyvinyl chloride, and this is what? Nylon 6,6, which is a fiber, right? So how it is forming? Hexamethylene diamine and adipic acid. Okay, so fiber. So A2 you can go. So A2, which is there in the second option. Yes. Then next, this is urea formaldehyde. So where is this? Urea formaldehyde polymer. So which is see here, this one is urea that will not be reused, right? That will not be reused. So I can go 4B4, that will not be reused. Elastomer, no, 4B, B3, B4, no. Thermosetting, thermoplastic, C4, yes. So thermosetting we can say. So C, D, that cannot be reused. So where we will be using that? So we will be using for making switches, Nevolac, all those things now. So that will be used for switches and all, for making of switches. So from that, see, even by knowing 1 or 2 options you can eliminate. So I told you fiber, nylon 6, and this is what? Urea and formaldehyde polymer I also told. Okay, then from that you can This one is a urea formaldehyde, so C, okay, 4C, so which is here only. Next 153. So maltose, so it is a disaccharide na, so how it is made up of? It gives 2 monosaccharides, okay. So what are those 2 monosaccharides? Glucose units na. So what are the 2 glucose units? One is see what they are asking, maltose and hydrolysis give 2 monomers, yes, correct only. Which is incorrect about monosaccharides? So both are alpha D glucose, yes, they are correct only na, because maltose is made up of 2 glucose units, so those are alpha D glucose only. So one is alpha D glucose, beta D fructose, this is incorrect. So this is something like sucrose, this is not the maltose. So they are also asking about incorrect one, na? The incorrect one, yes, second statement is incorrect about this question, okay. 154, identify the pair of drugs that act as antihistamines. So dimetapine, Selden. So what about this heroin, codeine, all these are narcotic drugs now. So they are asking about antihistamine, dimetap only, okay. Next, chlorination of this thing, what happens? So this electron ring activating at ortho para positions, actually this is ring deactivating, but directs the incoming electrophile to ortho para position. So nitration takes place at para position and ortho position, but major one is at the para, okay. So what is our X here? So our X is this one, nitro group, okay. So now we are treating this NaOH and at 443 degree Kelvin temperature. So now what happens? Cl goes out, OH minus is a good leaving group, that will replace as Cl. So this is our product here, okay. Hope it is also clear. Now we got X and Y, what they are asking, identify the major product Y in the sequence. So this is our major product. Let us look about the options. Yes, second option is there now, that is our major product. Next, so this is anisole. So this is a frequent question in all the exams, like NEET favorite question, that is first option, NEET's favorite question, previously we have seen, okay. So this is from ethers chapter, okay. So this, when we treat with HI, so what is the product formed? So we will get alcohol plus methyl iodide. So these are the options, X and Y we got. So X upon treating, so this means this should be X, this should be Y. So when we treat this phenol with zinc, okay, zinc, so what is the product formed? It will be benzene ring, okay. So this is benzene. So Y upon treating this with benzene C6H6, okay, in presence of AlCl3. So this is this iodide and this AlCl3 will remove out and we will be getting a benzene with CH3 group on its position Z. So this is our Z. So what they are asking, what is Z in the given set of reactions? So this is methyl benzene is the Z. Let us look into the option which is methyl benzene here. Yes, so here we have option number 4 which is methyl benzene, okay, that is our correct question answer. Which are the following reaction is an example of Clemmensen reduction? So in Clemmensen reduction what happens? Carbonyl group, CO group will be converted into CH2, CO to CH2. It means methylene is formed in acidic medium with zinc amalgam, right? So where do we have zinc amalgam? See, CO group is converted into CH2. So what is the conversion? Remove this oxygen, replace with 2 hydrogen. That is our product, okay. Let's move forward. Which of the following can undergo HVZ reaction? So there should be, for carboxylic acids, there should be 1 alpha carbon at least, and on that alpha carbon at least 1 hydrogen should be there. That is what? Alpha hydrogen should be present, yes. So in this compound alpha hydrogens are present. So here it will be converts into alpha halo product, like CH, COOH. So remove 1 hydrogen and replace that with chlorine. That is what happens in the HVZ reaction, okay. So what is the primary condition here? We required 1 alpha carbon and that alpha hydrogens are present, okay. That in those cases only this HVZ reaction takes place. See, here we have carboxylic acid, but there is no alpha carbon to this, okay. If this is a carboxylic acid, so this carbon, adjacent carbon is alpha carbon on which hydrogens are present, right. So reaction taking place in this, but to this might be the alpha carbon, but there is no alpha hydrogens on that. So no reaction in this first case, can takes place only in this kind of species, okay. Let us discuss about See, HVZ reaction only takes place in carboxylic acid, not these aldehydes and ketones. Now, two last questions here we have. Which of the following has the least pK? Yes, so I will be giving you one small hint. You have to solve along with me. I will be giving you 1 minute of time here. Okay, which of the following has lowest pK? Yes, tell me which is having lowest pK. So, more acidic, low pK. So, out of these, see, we have phenols, carboxylic acids, and with electron releasing group and electron withdrawing group. Now tell me, so which carboxylic acid is more acidic? Tell me first, phenol is acidic or carboxylic acid is acidic? So based on that you can easily answer. Now take 30 seconds and give me the answer for this. So tell me about carboxylic acidic strength. We already discussed in every class, every question paper we will be getting a one question on this carboxylic acidic strength. Okay, I mean acidic nature of these compounds. So carboxylic acids are always more acidic than these phenols. Remember that point. After that, if any electron withdrawing group is present at ortho or para position, so that makes it more acidic. Okay, so if any electron withdrawing group is present, see here nitro group is having which is strong electron withdrawing group, therefore its acidic nature is more than any of this carboxylic acid. Okay, so now out of these two, which is more acidic? So we know carboxylic acid with electron releasing group more acidic. Then next, out of these two, here it is electron releasing group and this is electron, there is no group. So electron releasing groups decreases the acidic nature, electron withdrawing group increases the acidic nature. That's why 4 is more acidic than 2, 2 is more acidic than 3. So this is what the order you can remember. So finally what is our answer? Fourth option is correct for this. Okay, and then next correct statement about the product B and C in the given reactions. So what is a product? So alcohol is given, ethyl alcohol is given with acid and Lucas reagent. So from that remove this H plus, add this H plus to this OH group and remove water and replace that with Cl. So we will be getting ethyl chloride. So what is this? So this will be CH3 CH2 Cl. Okay, so now we are treating this with ethanolic AgCN. So we will be having AgCN. Actually AgCN will be having more coal in nature here. So now this will be the attacking agent, I mean nucleophilic side. Now if it is attacking from nitrogen side, we will be getting CH3 CH2 NC isocyanide we are getting. And if in case sometimes it can also attack from this carbon, so in that case we will be getting cyanide as a major one of the product. These are the two possible products. Okay, so now B and C, yes, this is cyanide, this is isocyanide. Both are how they are related, they are functional group isomers. Yes, first statement is correct. Okay, then next with H2, catalyst B gives with H2 and catalyst B, with H2 and catalyst B gives primary and 2 gives secondary amine. So this becomes primary amine and this will become secondary amine. That is correct only. And B on acid hydrolysis gives formic acid and C gives C3H5. Okay, no. Let us see one more thing. C forms isocyanate. Yes, C forms isocyanate with HGO. Okay, so these like it will, see, whenever I treat this with Hg, so it will become CH3 CH2 NCO. This is what isocyanate. Okay, HGO we need to treat with HGO. So this oxygen is taken by this isocyanate group and becomes isocyanate and plus Hg. So this is also correct. So our fourth one is correct. B, second one, first one also correct. So let us see what are the options here they mentioned. Yes, so first one is correct, fourth one is correct and second one is also correct. So except 3, everything is correct here. So this is about 20 25 chemistry EAPCET question paper. Okay, so there is one question where we have felt little difficulty, that is from what, chemical kinetics, and that is also easy question only, but I need to verify whether everything is went well or not. Anything mistake in the print in the answer sheet in the key, or mine is mistake, I need to check it once. So after that we will be covering that question in the upcoming session. Okay, I do not want to waste the time here, so we will covering that question in the upcoming session, and you can also stay tuned with us for more updates on this paper discussions and everything. If you are facing any difficulties, you can share with us, we will be rectifying, or we will be sorting it out for you. Okay, thank you for watching.